So in this video we're going to try and derive a general formula for the integral subscript n, so that's the integral with the power of n, is this one here, x to this power of n ln x dx. So let's work out how we can do that. Well, we've got two functions of x here, log and x to the n, so we're going to need integration by parts for a start to try and integrate this first off. So let's go with that. So integration by parts, what we need is the integral of u dv equals uv minus another integral of v times the derivative of u. So this is our original integral, and then we've got this here which is part of our solution. So we need to work out which is going to be which. So if you pick up u, we know that u is going to be differentiated. If we pick up v, it's going to be integrated. So for this one, I'm going to take the derivative of log. So I'm going to let u equal log of x. So u is log of x. So therefore du equals 1 over x. Okay, so now my dv is going to be x to the n. So I'll write that here. dv equals x to the n. So to integrate that, I'll have v equals x to the power increased by 1 and divide by that new power. So that's my building blocks to get to the answer. So, okay, so let's start again here. So in is this. So I subscript n is that. So this then equals this and this. So u times v, so this one times this one. So I've got log of x times x to the n plus 1 all over n plus 1. That's part of the answer, so that's ready to go. So now I've got a new integral which I need to subtract from this, and it goes v times du. So v is this and du is this. So I've got x to the n plus 1 divided by n plus 1 and times by 1 over x. So I can put an x in my denominator and with regards to x. Okay, right. Now this is fine, nothing much I can do with that at the moment, but this I just need to just tidy up. So I'm just going to bring this one down in a line here. So now I've got x to the n plus 1 divided by x is just going to give me x to the power of n. So now I've got x to the power of n, that's dx. And then this n plus 1, well, when we're integrating with regards to x, this is just a multiple. So I can multiply this by 1 over n plus 1. So if I bring this out here and bring minus 1 over n plus 1, then that's fine. So now I can just integrate this. So bringing this one down even more, just keep going with that. Integrating with that, it's the same as what we had here. So then I've got minus 1 over n plus 1 times by x to the n plus 1 divided by n plus 1. Okay, right, now what have I got here? So I can just multiply these across. So I've got minus x to the n plus 1 divided by n plus 1 squared. Okay, so that's just this part. So this bit now I'm going to bring down. So now I've got, so I'm going to turn it round the other way, it's easier for me to read. X to the n plus 1 times the natural log of x over n plus 1. Okay, now as that's a minus, I'll take that out of there and put a minus sign there. Now I'm not finished yet, I just want to tidy this up a little bit. So I've got n plus 1 and n plus 1 squared. So why don't I times this by n plus 1 over n plus 1, and that way then I'll get the same denominator for both. So now I've got n plus 1 times this, so n plus 1 times x to the n plus 1, natural log of x, and then this will make one fraction because I'm going to have same denominators, n plus 1 squared, and then minus x to the n plus 1. Okay, now I'm going to add my plus c in a moment, but first of all I think I'm going to tidy this up a little bit, because I've got an x to the n plus 1 here and here, so I could just factor this out a little bit. So then I've got x to the n plus 1, bring that out, and then I've got n plus 1 times natural log of x, so that's also in a bracket, and then minus x to the n plus 1, so now it's minus 1, and that's all over n plus 1 squared. Okay, so now I can add a plus c, my constant of integration. Okay, so now that's my general result for I of n. So now I'm going to do a general result for when n equals 7. Okay, so now let's work out when n is 7. So I of 7, that equals x to the power of 7 natural log of x dx. And let's work it out with the parameters of 1 and 2. So from the range of integration from 1 to 2. So then this will equal x to the n plus 1. So x, so let's just write it here, n equals 7. That's the important value here. So x to the n plus 1, so that's x to the power of 8, times n plus 1, so that's going to be 8 times log of x. So 8 log of x, and minus 1. And then we divide all of that by n plus 1 squared. 7 plus 1 is 8, squared is 64. Now here we don't need the plus c because we've got a definite integral. So then this is calculated from 1 to 2. So now let's plug in x is 2 and subtract it from when x is 1. So if x is 2, I've got 2 to the power of 8 times 8 natural log of 2 minus 1. And then that's all divided by 64. And then when x is 1, I've got 1 to the power of 8 times, so now I've got n plus 1, so that's 8 natural log of 1 minus 1, and that's also over 64. Okay, right, well 8 log of 2, I can bring the 8 inside the log and write that as 2 to the power of 8. Now 2 to the power of 8 is 256, so now this becomes 256 times the log of 256 minus 1. And I'm going to do I've got a common denominator here, so I'm going to come to that in a moment. In fact, I'm just going to write it in there now, just give everyone 64. Now let's go with this one. Well, log of 1 is 0, so this bit disappears, but I'm left with the minus 1. Well, 1 to the power of 8 is still 1, so I've got minus 1 times minus 1, which is plus 1, and it's divided by 64. So I've got a plus 1 there. So now that's going to be the answer of my integration. I've got 256 times the log of 256 minus 1 plus 1 divided by 64. Plug that into a calculator and you'll get something that is approximately 18.2. That will be my answer for when n is 7. And that makes a nice quick way of integrating this function here. Okay.